2 body parts, 3 body parts. So 2 ahead. Then you're walking that way. Where does this bug land? Where does this particle land? And the function wants to go to 1. Right, so it looks like I can't talk about things when I divide by 0, but by looking at the limits. And by approaching a point from the right and the left and seeing where the function wants to go, I'm allowed to sort of move on and keep studying this function near 0. Still can't plug in the speed limits, is that you don't have to. So we talk about the limit of this function. You can see that from the graph. You can play around with it. We can do a bunch of things. But our goal eventually is to develop and enhance our techniques to find limits using algebra and make algebra stronger. Right now we're sort of guesstimating based on the graph. This is a good place to gain some function. Another way to do this is you can also find limits using tables or calculator or other cell sort of properties. It's like numerical things. So let's do another one. So if I said take a function f of x, the square root of t squared plus 9 minus 3 all over t squared. Okay, this is a perfectly good function everywhere. You can evaluate this, but I, of course, am interested in, and this is where we're first going to start. What happens when t goes to 0? What happens around 0? Hopefully you agree. If you plug in 0, the numerator becomes square root of 9 minus 3, 3 minus 3, that's 0 again, and the denominator is 0. 0 is 0, that's undefined. I know you're never going to tell me that that's 1 or something like that. Just make me angry, give me more gray hair. So, I don't know the graph of this one. I could go look it up and do that sort of thing, but let's try another way. What you can do is you can make a table, and you can kind of see what's happening. So let's take some t values, let's plug in the function, and I worked these out before, but you can check these with your calculator. Because everything's squared, if you put plus or minus in, it's not going to change anything. So what I'd like to do is get closer and closer to 0. So here's 1, and here's negative 1. Let's plug in and see what's going on there at plus or minus 1. When you do that, you get 0.16228. I can go to as many decimals as you want, but get some decimal. Not surprising, square roots, fine. Let's move in a little bit. So with 0.1 is maybe like here. Okay, so let's move in a little bit. How about if we go to like plus or minus a half? So put negative a half and positive 1/2 on the map. Plus or minus a half. And you can check. If you plug in 0.5, plug in a half to this thing, you get 0.16553. Say, okay, this 0.16 is here, and it seems like it's kind of approaching this 0.16 number. If you get even closer, so it's like getting really close, going up a little bit, we can do plus or minus a tenth. And in that case, it turns out you can check a calculator, 1662. And you can get even closer, 0.05. So notice like I'm getting closer to 0, but I'm never quite plugging in 0. And of course, there are infinitely many numbers that are as close as you want to 0. It turns out if you get closer and closer and closer, here's 5.005, you get 0.16667. And eventually you sort of give up and say, okay, this thing is approaching like 1.666 and change. So your guess, and you don't really know this, but your guess in here, is that if I kept getting closer to 0, so as x gets closer to 0, from either the right or the left, doesn't matter, we seem to be approaching this 0.16 with a bar on it. We'll just keep going, and you can check that's 1/6. So it seems to be approaching, you'd say the function f of x sort of wants to go to 0.16 with a bar, which is 1/6. And this is our best guess. And if we were, you can get this as accurate as you want, as many decimals as you want. So this is one way to use sort of data to get a limit if you're not quite sure what the graph is doing. Now, there are functions that we should talk about that sort of still don't like when we play with limits with them. So let me do this as an example. How about the function f of x equals the sine of pi over x? You can check pause the video and go graph this thing in Desmos or something like that. I'm going to draw you a picture.